Hi, I'm Bill Grosser with the School of Ice and the U.S. Ice Drilling Program. In episode 2, Meredith is going to take us on a tour of ridges and plains. Those are two geologic landforms, and we're going to do exactly what she said at the end of episode 1. We're going to try to make observations and measurements to try to figure out how those landforms came to be. So take out your notebooks. We're going to write some things down. You can start by just writing down the basic definition of geomorphology so you have that. And after that, let's focus on ridges first. We're going to start by taking external observations and measurements of these ridges that are all around Dartmouth campus. And then later in the video, we're going to look internally. We're going to actually dig into one and see what makes these ridges up. So when your notebook is ready, you can just let the video roll. If at any time during this episode you need to hit pause to catch up, feel free to hit pause. Anytime you hit play, we'll just keep rolling. So let's join Meredith as we explore some of the ridges around Dartmouth campus.
So I'm walking here in Pine Park, a local park in Hanover, New Hampshire, located about a mile north of my office on the Dartmouth College campus. And this is a pretty incredible place. It's a wonderful place to take a walk on a shady path on a hot day in the summer. It's also a really incredible place to take a look at something called geomorphology, which is essentially a study of the earth and the shape of the landforms and the sediments that make up landforms on earth for the purpose of understanding how those landforms formed, what environments they register, and the processes that went into creating them. So this is a study called geomorphology, and it's essentially the question that we're asking here. What can measurements and observations of the surrounding landscape tell us about past environments? Okay, so we are here on the Hanover Golf Course, and we're going to walk up and check out this ridge or hill. For scale, you can see the dog Bailey in front here, and that little pink girl running towards us is my daughter Lila, who's going to be joining us for the rest of the field trip. Okay, so we are now on top of the hill or the ridge that we've been looking across the golf course at. And there is a view of my daughter running towards the south. Through the trees down there, you can see a pond. That's Occam Pond, where we started. And what I just want you to observe here is that there's a significant amount of elevation drop from the top of this hill. There's some sort of humpy, lumpy features on the side of the hill. So right now we're looking here towards the east, and I just want to scan down and show you what the shape of this hill looks like on this side, and then give you a chance to get a perspective. Okay, so we're walking here along the hill or ridge that we've already viewed from the Hanover Golf Course. Now we're actually on top of that ridge, and we're in a forest along a path, a really nice path that runs right along the top of the ridge, and it's here where I can really show you why I'm calling this a ridge. So we're walking pretty much due south here, and to the right of me, to the west, you can see there's a really steep drop off, and that side of the hill here is very steep. Well, if you look off to the left of me, also to the east, that side of the hill is also really steep, and that's why I would call this landform a ridge. And the surface here is actually really beautiful and flat, and makes for a really nice walking path.
Hey, if you need to pause right now, go ahead and pause the video and finish writing down anything you want about that aerial view of that ridge or anything that you noticed about the ridge as Meredith was walking along. When you're ready, you can hit play again, or if you don't touch it, it's going to start again in 10 seconds. So the next thing we'd like to look at is the change in elevation. Meredith mentioned that she was walking on a ridge and it was really steep. There's actually ways to measure how many feet you'd have to climb to go from the lowest point to the highest point. So here's an aerial view of that ridge, and we're going to look at that ridge a few different ways so you can really get in your mind conceptually what we're looking at here. We've circled the actual ridge where Meredith was walking. Now you say, I don't really see a ridge, I see a bunch of trees. Well, if we strip those trees away, you could actually see the landform that exists underneath it. This is called a LiDAR image, and that's exactly what this thing does. It doesn't see the trees, it only sees the landform below it. And now it's really easy to see that ridge that Meredith was walking on right there, with the trees, and again without the trees. So our challenge then that Meredith set out before us was to make some measurements so we could figure out how this landform came to be. Well, if we want to measure the change in elevation from that trail she was walking on down, we're going to need a different kind of a map. So we need what's called a topographic map. So here's a topographic map of the Dartmouth area. Now you need to know a little bit about topographic maps to be able to measure the change in elevation. There's our hill. And there's the path where Meredith was walking down. So we want to look and see how much did the elevation change from down by the river all the way up to the top of the hill. So to do that, we're going to need to know something called index contours. That green line is tracing the 400-foot index contour. That means it's 400 feet above sea level. The next dark brown line is 500 feet above sea level. So you have a little work to do. You have to count the lines. You have to figure out how much each line is worth in elevation. If one is 400, the next one's 500. Figure out how much each little line is worth. And then you have to pick 2 points. So I'm going to ask you to start down by the river and pretend you were hiking up that hill to the top, to the trail where Meredith was walking. And can you actually calculate how many feet of elevation you would climb going down that path? So we're going to pause the video here after we put it up a little bigger for you, and I want you to do the same thing. Just pause it, take some time, and make the elevation measurements starting at the river using the contour lines and pretending like you're climbing up that hill all the way to where Meredith was hiking. If you think you have your number, you can hit play again and catch up. Until then, take as much time as you need. I hope you got a measurement from the river up to the top of the ridge, and I hope you compared with some of your classmates or the people around you. Just make sure you're at least in the same ballpark. So those were our external measurements and observations. So next, if we want to figure out how this ridge came to be thousands of years ago, we need to look inside the ridge. So we're going to rejoin Meredith as she takes us around the ridge, and now she's going to take us actually not around the ridge, but inside the ridge to see what it's actually made of.
So we're in Growbrook Valley in Pine Park here, and we've walked down to find this exposure, what I call outcrop, into the sediments that make up the valley walls on the sides of the brook here. The brook has done this incredible job of eroding down into the valley, exposing these sediments. And the sediments that we're looking at here make up the ridge or the hill that we were looking at on the Hanover Golf Course. And we'll have a more detailed image that shows the sediments in this ridge. What we want to start thinking about is how to describe these sediments. And by that I mean, first of all, what grain sizes the sediments are. Are they small, medium, or large? And what are the shapes of those grains? And what's the sorting of those grains? And we'll think about that a little bit more using the still image and the detailed up-close image of the sediments.
All right, if you can open your notebooks back up, it's time to take some notes now on the internal structures that we see inside this ridge. So in your notebooks, we're going to ask you to write down observations, and we're actually going to ask you to measure some things using a tape measure of these particles as well. So the first thing we want to look at is the size of the particles that make up the dirt under the ridge. So in your notebook, we're going to ask you to choose between a couple things. You can choose, yes, I see clay or sand or silt or mud. Those would be really small particles that are hard to see. Sand would be exactly what it sounds like, or gravel and pebbles would be big things. After that, we're going to ask you to describe the sorting of the particles. Does it look like all the particles are about the same size? Or does it look like there's like a random mix of all different size things? It's very important when you want to look back and figure out how this thing came to be. After that, we're going to start looking at the actual structures. When you look at where she's dug away from the side of the hill, do you see specific layers? Like a cake all layered up? Or does it look like just a random mess? Last but not least, we're going to look at the actual particles themselves. Do they look rounded and smooth? Or do they look all jaggedy and rough? And when we're looking to see if they're rounded or smooth, if you can see the particles, we're actually going to measure them with a tape measure. So that's a lot to do. I'd also like you to sketch a picture of what the particles look like in your notebook so you have that for the future. Just like always, if you need to pause the video, and when you're done doing all that, you can hit play and then we'll continue. Hey, welcome back. If you've hit play again, that means that you're done with all your notes and observations and measurements about ridges. I would like to ask that on the right-hand page that you include a little placeholder for geomorphology interpretations. And Meredith is going to join us again at the end and share with us what she sees when she looks at all those measurements and observations. So with that said, let's go on to our second geologic landform. We're going to now move on to something called a geologic plane. The geologic plane looks like a kind of plane, all right, but it's not. There's a lot going on there. So this is a geologic plane, P-L-A-I-N, and we're going to look at two different geologic planes. One is out on the golf course right next to the ridge where we were walking before, and the second is right in the heart of the campus of Dartmouth. It's called the Dartmouth Green. All right, so we're going to do the same thing that we did before. We're going to take external observations and measurements, starting with just a general description of a geologic plane, and Meredith is going to be joining us on the Dartmouth Green to start this exploration. We have zoomed back and come in all the way from the satellite so you can see where Dartmouth is if you're not familiar where the Dartmouth campus is. And as we get closer and closer, you'll see the plane emerge, and there it is, the Dartmouth plane. So back to Meredith.
Okay, we're here now on the Dartmouth, or what's called the Hanover Green. It's a big, green, relatively flat area, actually very flat area. And my daughter's here doing gymnastics. It's a really popular location. People sit out here and have picnics, they play frisbee, they play football. It sits in the middle of pretty much the main part of campus, so students cross here every day to go between classes. And I want you to take a look at this with a different perspective, with the perspective of a geomorphologist. So we want to think about this as, what kind of landform is it? And that might seem like a weird question because this area might seem developed and perhaps even really modified by the college, but in fact it's not. And these very flat surfaces occur all along the edges of the Connecticut River Valley, between Hanover, north of us, and then even to the south, as far south as into Connecticut. So let's take a look at this. This over here is Baker Tower, Baker Library, and I'll refer back to that in a little bit. And we're going to be able, in a couple minutes, to take a look at the sediments that actually underlie this landform.
All right, hopefully you got down the general description. Next, we'd like to actually calculate the change in elevation across a plane. So we're going to do it the same way that we did with the ridge. We're going to get out a topographic map and use those contour lines to see how much the elevation is changing as you go across a plane. The plane that we're going to look at is the golf course. I think that we have the topographic map already of that area. So let's go back to the golf course. But instead of looking at that ridge like we did before, we're going to move down a little bit and look at the plane. So here's an aerial view showing the ridge on the left, and you can see those 4 fairways just to the left of the road. That is actually the geologic plain, and it continues on across the highway over into those soccer fields. So what we'd like to do is find a place starting on the left and moving all the way to the right, and then calculate the change in elevation as we move across this plain. Now remember, we're going to need a topographic map to do this, so let's bring our topographic map back. And if we zoom in on the topographic map in the exact same area, it's interesting. On the left-hand side, there's an old ski jump that used to be on the hill. On the right-hand side, there's a creek that goes into a neighborhood, so that's the line that we're going to examine. The elevation changes across that. So let's start at the top of the old ski jump, pretend like we're walking all the way across that plain to the creek, and pause the video and try to figure out how much does the elevation change starting at the ski jump, ending up at the creek. Go ahead and pause the video, take as much time as you need. You might want to compare your notes with your classmates, and when you're done and you think you have the elevation change, you can go ahead and hit play, and we'll continue. If you've hit play, that means you're probably done with all your external observations. Well, now we're going to look internally at this thing called the geologic plain. So we'd like you to get your notebook ready, and then we're going to rejoin Meredith as she takes us like underneath the Dartmouth Green so you can see actually what the sediment is underneath there. So in your notebook, let's put the same types of things that we did when we looked at the geologic ridge. If you could start by describing the particle size once we look at those pictures, and we're going to use the same terms, either mud and silt kind of stuff, or clay. Sand would be middle-sized, looking like sand, or gravel would be huge pebbles like you maybe saw last time with the ridge. After you describe the particle size, we'd then like to go on and describe the actual sorting of the particles. And again, what we're trying to decide here is, does it look like there was something going on geologically that sorted those particles into nice uniform kind of pieces, or is it just a random mix of everything? After you describe the sorting, we're going to then describe the structure underneath these plains. Do you see any layers, distinct layers, or does it seem like just a random mix like there is no visible structure? It again tells us a lot about what might have formed it thousands of years ago. We also want to talk about layers. Do you actually see specific layers, or do you not see layers? And last but not least, we're going to make a sketch of it. So we'll show you a very close-up piece of this geologic plain that was pulled from underneath. And if you have all that in your notebook ready to go, we're going to go back to Meredith, and she's going to take you right across. If you need some time to catch up, hit pause. If you're ready to go, hit play.
So how do we learn about what makes up these landforms that are the flat surfaces? Well, we can look for places where there are exposures underneath the flat surfaces. Now I've included a couple images of these. One of them is from actually on Dartmouth campus itself, where you can see excavations into buildings that were being built. There's one where you see a professor, James Goldthwait, at Dartmouth in the 1930s looking at a new excavation into a building, and you can see the sediments below that. There's also another photo that I took more recently while Dartmouth was working on the pipes that traverse the sediment below campus for the heating of Dartmouth campus. In both of these, we'll come back and we'll make some observations about these sediments. We're standing here in the Girl Brook Valley, and this valley, the brook itself, has done an incredible amount of work to expose the sediments that underlie the golf course and the Dartmouth College campus by down cutting. So the stream has actually cut down into the landscape itself, flowing down to the Connecticut River, and exposed these sediments. And what you see here is a beautiful outcrop of these sediments. I'll walk up a little closer here. So we have some detailed still images of these sediments that I'm going to call varves. And the first thing I'd like you to do is describe what these sediments are. What are their grain sizes? You can use the terms small, medium, large. Geologists like to call grain sizes by names that are clay for very small grain sizes, silt a little bit bigger, sand and gravel for the biggest grain sizes. What's the sorting of these sediments? And that means, are there all one size sediments, or are there more than one size to these sediments? And are there any structures to these sediments? And by that I mean, are there any layers to the sediments? And I think you can start to see that here and also in the still imagery.
Welcome back. Hey, if you're done with all your observations and measurements, on the right-hand page, please make room for geomorphology interpretations. Meredith is going to join us and tell her what her impressions are when she looks at a plane. So now you should have 2 pages left for interpretations, one for our geologic ridges and one for our geologic plains. And if you have that ready to go, we're going to turn it back over to Meredith to share her thoughts and interpretations on how these landforms came to be what they are today.
Okay, so this is Meredith again, and we are back here to where we started, which is on the Hanover Golf Course. And I want to try to wrap some things up here. So we've seen a lot, and you have started to make some measurements and some observations. And so I want to take those observations and make some interpretations based on them. So we've looked at 2 main landforms, the ridge and the plain. And in the ridge, let's start with that one. So the ridge you can see out here actually to my left, to the west, and we noticed that it was a ridge. You made measurements about how high elevation or high relief that ridge is. And then we looked at the sediments and we saw that they are this coarse grain, this larger grains. They were sand and gravel, and that gravel was rounded and there weren't any layers in it. And from this, as a geologist, the way that I would interpret this is that this sediment had to have been transported by pretty fast moving water. And the environment that I think of when I think of fast moving water is some kind of really high powered stream. Okay, so this is the way that we'll interpret that, and you may be scratching your head a little bit and thinking, that's weird. Why would a stream, which you usually think of as forming in a channel, actually take the form of a ridge? And that's curious, and you should be thinking, that's a little weird. I don't believe her. But come back in episode 3 and we'll work through that and talk through that and think about how a stream, particularly a very fast flowing stream, might take the form of a ridge. Okay, so the second feature that we've looked at is what we've been calling a plain. We saw that on the Dartmouth green. We also you measured that on the topographic map in a place on the golf course, and I hope that what your observation showed is that the landform itself is very, very flat, and the sediments that we looked at in this landform are very small in size. They're mostly silt, clay, which together make up mud, and there really is no larger grains in there. And then they have this cool structure. They're layered. They have thin layers throughout the deposit that we looked at. And the way that we're going to interpret these, and the way that I see these as a geologist, is to get very, very small sediments deposited. In many ways, you have to have a quiet environment where those sediments can either settle out of wind or water. They're also pretty well sorted. There are no larger grain sizes in there, sediment sizes in there. And a couple of the best environments to do that are out in a deep ocean and also in a lake. And that's in fact how we're going to interpret this landform here, is the very flat surface, and the small sediments that make it up are the bottom of a lake. So those small sediments settled out in the water in the lake, and we're able to form a very, very flat surface that we'll call a lake bed. So together our observations show that in a time in the past, Hanover had very flat, fast-flowing stream and lake. So these are obviously not here right now, and the sediments are not yet made into rock, so that tells us they're pretty recent. And in the recent geologic history of Hanover, one of the biggest events is that there was this large ice sheet that covered the area. Again, we talked about this at episode 1. It covered most of northern North America, and as the climate warmed at the end of the last ice age, this ice sheet started to melt and recede, and as it receded through this area, it had a lot of water associated with it. So in episode 3, we're going to tie the fast-flowing stream and the lake into the recession, or the melting of this large ice sheet through this area, and we're going to figure out how we can use these landforms to understand how we can look at how fast ice sheets retreat through an area, and that this is important for understanding how ice sheets are retreating today. Okay, I'll see you in episode 3. They're very well sorted. There's no coarse grain or larger sediment in it. And they have this really cool structure. Hold on one second, yes?
Are we going to go to the same place where I ran around and did cartwheels?
We can if you want.
I want to. I want to go to the circus.
Okay, go pro stopper.